And now we can talk about blood. This is the only connective tissue that has a true liquid matrix, blood and lymph, that is. The others all contain fluid, but they're not a liquid. The liquid aspect allows the blood to deliver nutrients, salts, and wastes to necessary compartments in the body. The pink cells in this picture are red blood cells, and the larger purple one with the dark nucleus here is a white blood cell. Sorry, my dog just sneezed and made me jump. Gesundheit. And so the blood flows rapidly through the body and it delivers nutrients to different tissues that need it. And a lot of that nutrients is like sugar or oxygen. And it also carries carbon dioxide back to the lungs to be expelled. You good, Riley? So then we got lymph. It contains a liquid matrix and white blood cells, similar to blood. This liquid, however, delivers nutrients like fats digested in the intestine to the blood, and it acts as a drainage system to allow excess fluid from interstitial spaces to overflow into. Also, one thing I wanted to note here before we move on is that the extracellular liquid in blood is what we call plasma. But yes, blood and lymph are the only true liquid matrices of connective tissue. And then we have muscle tissue. We have skeletal muscles, which is going to be characteristic of long cylindrical fibers, be really striated, a lot of different nuclei. This will be with voluntary movement, help produce heat in our body, protect our organs. This is what's actually attached to bones and around entrance points of the mouth and the anus. And then cardiac is what's around our heart. This helps contract so that blood pumps. And then smooth muscle is going to be usually around the walls of our major organs and passageways. And so think of your skeletal muscle as producing heat for our body. It's how we are walking around at 98 degrees because our skeletal muscle is contracting, creating heat, releasing heat. And so this is not a connective tissue. Muscle falls into its own category. And just think, if you think of muscle, think of contraction. That's what helps us move. So skeletal muscle looks really long. You can see a lot of different nuclei. Smooth muscle looks a little bit less straight, a little bit less visible with the striations, only one nucleus. Cardiac muscle will appear striated and have one nuclei. But again, all three of these we'll talk about later in the semester as we get to these different systems. And then we have nervous tissue. Once again, we'll talk about it more when we get to it later in the semester, but you can find nervous tissue in the brain, your spinal cord, or in nerve fibers throughout your body. They're the only cells that are capable of conducting electrical signals. So the large star-like cells are the actual nerve cells that conduct electrical signals. The small dots, you can kind of see, the small dots are neuroglia. And these are not connective tissue either. Neither the nervous system, neither of these nervous tissues, neuroglia or neurons, are connective tissue. They're their own classification. So the neuroglia are going to help nourish, protect, and insulate neurons. There's a lot of research coming out recently about different functions of neuroglia, but for our aspects, we're just going to say that they support nerve cells. Okay, so now that we got through all the different types of tissue, we just need to make sure that we're aware at this point that none of these tissues exist alone. You won't just find an epithelial cell. You'll find an epithelial cell associated with other types of cells, or tissues, I should say. In many cases, we find many different tissue types in one area of the body, and they exist in layers. Each tissue type or layer provides a unique function that contributes to the well-being of the rest. So here we can point out three different types. You can see a smooth muscle. We can see an epithelial layer. It says endothelium. It's basically the same thing. It's an endothelial layer on the inside. It'll be a little bit smaller, more flat-like, so it can exchange nutrients. In this scenario, it's an artery or a vein. And then on the outside, you'll see another layer of epithelium. But then what we can see I'm sorry, I just said epithelium on the outside. This is connective tissue on the outside. And so you can kind of see those three different layers here as well. You can see the connective tissue on the outside. Oh no, connective tissue on the outside. You can see a smooth muscle layer on the inside. This is just so that it can be contracted to close or open for vasoconstriction or dilation purposes. You gotta be able to change your rate of blood flow based on if you're hot or if you're cold or if you're excited or whatever the case may be. And then the inner layer is the endothelial layer where the blood is actually touching. All these layers, again, are contributing to the functioning of the organ, and they won't exist by themselves. They're in layers. And so the regenerative capacity of different tissues varies. And so we can think of 3 different classifications of types of regenerative capacities. And this is basically saying whether or not these cells are dividing throughout life. So we can say that they regenerate really well, moderately well, or they just don't do it at all. And so we kind of talked about this last week in mitosis, but epithelial cells and like blood or bone need to be able to regenerate regularly, and these are considered labile, and they divide throughout life. If damaged, they can completely regenerate. These cells are most impacted by chemotherapy agents, which end up targeting rapidly growing cancer cells. And as a result, you lose hair or anemia, generate low immunity, have messed up GI tract, which is the epithelial tissues, get mouth sores. Labile cells are destroyed along with the cancerous cells because they're mitotically dividing regularly. And these are what we're targeting, is the cancerous cells that are just growing too fast. Stable cells are those that can regenerate when they're injured. And so like the liver, the pancreas, or other glands are examples of stable cells. And then we have permanent cells that have very limited ability to regenerate, if at all. Neurons are an example of this, as well as heart muscle cells, I should say. This is why a heart attack and a stroke often result in permanent damage and can't be reversed. Continuous research is trying to find ways to coax these types of cells to regenerate, but as of right now, these cells are just dead and end up just being space. And so, like when in the case of a stroke, a little chunk of brain tissue or a bunch of nerves died, and neuroglia will go in and eat all that away, so it's not just going to get infected or anything, and then there'll just be a space or a cavity there. And so you can literally see this in different pictures of stroke incidences. And then we can talk about tissues that are able to be repaired. And so when a tissue is damaged, there can be a substitution of new viable cells for those dead ones or damaged ones even, that just need to be shed. And so you can think of this as in the skin. And so we have a primary union, and this is when the edges of the wound are close together. Think of if you just took a knife and just made a slit. The wound will fill with blood, clot will form, the scab will appear, it might pus a little bit, a granulation will occur on the bottom, and then a scar will form. A secondary union is when the edges of the wound are not close. If you think of like a laceration, something that's really large, the clot might not be able to close that gap. There'll be a stronger inflammatory response, and the wound contraction will it will end up leading to a larger scar typically. And so a secondary union is when a large skin injury has occurred and some of the skin is lost at the edges, and it's typically going to have a significantly worse scarring. And so we can kind of see that here. Notice the skin heals from the inside out, and so inflammatory chemicals are released from the injury, and white blood cells are seeping into the injured area from the bottom, not at the top. And so the opening will still be there, but this is why this is why patients that are out of surgery are concerned about their incision still being open, but in reality they only see the surface and they don't see the bottom where the wound has closed, but the skin has sealed in the deeper layers and the surface layer is the last to close. And so you can think of this last aspect of the healing process is this granulation tissue restoring vascular supply to that tissue and being regenerative. And there'll usually end up being a scar as well. But other than that, that is the last part of the tissue lecture. And next we'll start talking about the integumentary system.